Hi students, this is Mr. Yao. Today we are going to talk about 6.2 where we will learn about chords, tangents, and inscribed angles. Let's first review some prior knowledge. First one we are going to review is the tangent segment theorem. Just like it says in the name, we are going to be looking at tangents. That means they are only intersecting with the circle at one point. And we're also going to be looking segments. So here's the description. Tangent segments from a common external point are congruent. So just like in this little graph on the right side, the external point is S, and from S you can actually send two tangent lines, this one and that one, and they are congruent. If you would like to prove it, here's kind of the idea. If you connect them with the points, these are going to be 90 degrees, and these are both going to be radii. And here, if you connect the PS, these two triangles are actually going to be congruent. That's why SR and ST are congruent. It's actually congruence by HL, because these are right triangles, so you just need hypotenuse and a leg to prove they are congruent. Next one that we have talked about is tangent line theorem. This time is going to be a line that's going through and intersecting with a circle at one point. That line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint. So basically it's saying, since we're only intersecting at one point, if you connect this point with a radius, it's for sure going to be 90 degrees if that line is a tangent line, or if you want it to be a tangent line, you just need a 90 degree. That's why it says if and only if. Now two questions to review. First one, because that's their tangent segments, they are the same. So 3x plus 10 equals 7x minus 6. So if you subtract 3x on both sides, that's going to give you a 4x on the right side and a 16 on the left side. So x equals 4. Question B, R is the radius. And because that's a tangent, we actually have 90 degree and a Pythagorean theorem that we can use for the right triangle. So r squared plus 9 squared equals 2. The hypotenuse is r plus 6 being squared. So r squared plus 9 squared. Remember, 81. Remember to write it twice, so you need to distribute. That's going to give you r squared plus 12r plus 36. R squared is going to cancel. 12r is being left on the right side. We're going to need to subtract the 36 to the left side, and that is going to leave us with a 45. Divide both sides by a 12. R is going to be a 15, actually. A 15 over 4. That is question B. Moving on. We are still going to use what we just talked about, but this time we're focusing on the angles. Find the missing angle. Something that the question should have said is these two lines are going to be tangent to the circle. That means these are going to be 90 degrees. So first way, there are several different ways. For all of these angle questions that we are going to talk about in this lesson and the next two lessons, you will notice there are many different ways. As long as you follow those theorems and they actually work, that should be the right answer. So these are 90 degree angles, and if they are 90 degree and this angle is currently 26 degrees, that would mean the leftover from the 90 degree is going to be 64 degrees. And that is 64 degrees. These two sides are the same. That means this is also 64 degrees. If that's the case, we can just use 180 degrees minus 64 degrees minus another 64 degrees, and that's going to leave our question mark to be 180 minus 128, which is 52 degrees. That is the first method. Now here's the second way. If we already know that angle is 26 degrees, and these two are both the radii, we can also know that is 26 degrees, and that means the leftover, the central angle, is going to be 128 degrees. Then we can look at this quadrilateral, because they make up 360, and these two angles are both 90, so it's still the same idea, 180 degrees minus 128 degrees, which is 52 degrees. That works too. So these are two of the main method. Example 2. That line is tangent line, so that makes this a 90 degree. And we're being asked to find the question mark. There are several different ways. One, you may notice that these two are both the radii, so that makes this 61 degrees, and if that's 90 degrees, this leftover part is going to be a 29 degrees. And if that is 29, since this is a straight line, we can also find out this angle is going to be supplementary to the 61 degrees, which is 119 degrees. So now all we need to do is use 180 minus 29 minus 119, and that is going to leave us with 32 degrees. That is one method. Here's a different method. Since we already know these two are both 61 degrees, that leaves the central angle to be 100 minus 122, which is 58 degrees. If that is 58 degrees, we already know this is 90 degrees. We can look at this triangle. Question mark is going to be 180, or we can actually directly use 90 minus the 58, which is also 32 degrees. That is example 2. Moving on, we have some more. Chord's theorem. If a diameter of a circle is perpendicular to a chord, as you can see here, this is the diameter, and just a random chord. If the diameter is actually perpendicular with a random chord, then the chord bisects the chord. Then the diameter bisects the chord and its arc. Bisect means cut into two equal pieces. That's what bisect. Sect means cut, bi means two parts, and these two parts happen to be the same, so that's what bisect means. This is basically saying these two parts are going to be the same, and these two arcs are going to be the same. If you would like to prove it, here's the method. You can connect the center and F and connect the center and D. These two parts are both going to be the radii, so they are the same, and they're both 90-degree triangles, and we already know they share that side. So it's going to be a triangle congruence by, that is called HL. So this is the same method. Connect CD, CF, and then use these two triangles to prove triangle congruence. Then, of course, these two parts on the bottom are going to be the same. So that is Chord's theorem. Now we're going to use it for some examples. Example 3, find x. X is being labeled as the radius, and from what we just know, if that is 90-degree angle, that means these two parts are going to be the same. So the part on the left is also a 10.6, which means we can use Pythagorean Theorem to set up this whole thing. 10.6 squared plus 4.3 squared equals to x squared. So now if we want to solve it, we are just going to square root both sides, basically. But you got to square root everything on this side. So I'm going to type in my calculator and see what I'm going to get. After type it in, x should be 11.44 for the radius. Example 4, same idea, but this time it's asking for this little part of x. If you want to know that, you do need to know this question mark. And since that is a 90-degree angle, these two parts are going to be the same. And even though that is a number, but it's actually given the diameter, we, however, need the radius so that we can actually have the right triangle. So 35.2 divided by 2 is going to be 17.7. Now it's time to set it up. Question mark squared plus 13.9 squared, because again, this part is 13.9, equals to 17.6 squared. So if you try to solve for the question mark, that is going to be 17.6 squared minus 13.9 squared. And of course, take a square root on both sides. And if you type in your calculator, that should give you the question mark as 10.795. So round up is going to be 10.80. But that's just a question mark. We're trying to look for the x. X, however, is going to be the radius minus the question mark, which is going to be a 6.80. That is example 4. Next, inscribed angle. Inscribed angle is something we kind of have defined already. It is an angle whose vertex is on the circle and whose sides contain chords of the circle. basically saying if there's a point on the circle and you just send out two random chords and extend them, you are going to intersect with the arc, and that part is going to be called the intercepted arc. So intercepted arc, again, the definition, the arc that lies in the interior of an inscribed angle and its endpoints on the circle. Next, measure of an inscribed angle theorem. So here you can see this is going to be the inscribed angle that we are looking at. This theorem is basically saying that angle is when you compare to this part of the arc, because that part is being cut off by the house, by the angle actually. So if you actually look at that arc, this inscribed angle is going to be half of that arc. So that's what here it is. Angle ADB is half of arc AB, or you can think it as also it is half of the diameter. So that is the inscribed angle, measure of inscribed angle theorem. Let's use it for some questions. Find the value of question mark. So that part is 90 degrees, and you see a little diameter that's going through the center that for sure means on both sides is going to be 180 degrees. So when you try to find the value of question mark, it is facing 90 degrees right here, because that is the inscribed angle, and you are going to use half of it. So question mark is going to be 45 degrees. Next one, question mark is right there. 45 is facing the question mark, so you just need to divide it by 2. 45 over 2 is going to be 22.5. Next, we have a question mark, but this time the angle that is facing is not given. Here's the angle. However, you're given the other side, which is 118. So if that angle itself is 118, that means the arc is going to be twice of that, which is 216 degrees. And if that is 236 degrees, that would leave the rest. So we're going to use 360 minus that. That means the rest, which is this part, is going to be 360 minus 236. So it is going to be 124 degrees. So question mark will be half of that, which is 62 degrees. Next, if that part is 121 and this part is 157, and the whole circle is 360, we can use 360, subtract 157, and subtract 121. That means we are subtracting 278. So that is going to give me 88 degrees as the arc. So the question mark will be half, which is 44 degrees. That is example 5. Oh, I just realized they actually add up to 178, so I have 82, which means this is actually a 41 degrees. Next, example 6. Find measure ABC, that angle, and measure of DC. I'm pretty sure that's a typo. This should be ADB. And ADB is just half the arc that is facing. That is going to be 38 degrees. And then DC is 45, that's facing. So that times 2 is going to be 90 degrees. Number 7. Find a measure of angle T and a measure of QR. So first, we already know this is 50 degrees. So that is the arc that is intercepting. That means this is going to be 110 degrees. I'm not 110, 100 degrees. And next, if we want to find T, it's referring to this little angle is going to be half the arc is facing. So that is 24 degrees. And if that is 24, and we have a diameter right here, which indicates this half of the circle is actually a semicircle, which is 180 degrees. So that means my QR is going to be 100 minus 18, which is 40 degrees. Oh, sorry, that is actually 18 degrees, 80 degrees. Okay, that's example 7. Next, example 8. Solve for x. Well, this is the inscribed angle, which is 16 degrees. That means the arc is going to be twice of that, which is 32x. Now I actually have every single arc on the circle labeled. So all I need to do is add them all together equal to what? 360. So 32x plus 16x plus 5 plus 16x plus 22x plus 5. So that is going to be together equal to 360 degrees. So I have 54 and 70x plus 10 equals 360. Subtract 10 and divided by 70. That is going to leave x to be a 5. That is example 8. Last one, example 9. If that angle is 80 degrees and that is 78 degrees, I can add them together to be 158 degrees, and it is facing the angle right here. And that angle is going to be divided by 2, 79 degrees. However, if we found the other side is 158, we can also know this side is going to be 360 minus 158, which makes this 202 degrees on this side. But still not fully done because we need to solve for x. This angle is facing the angle we just solved for. So that means 9x plus 11 is going to be half of 202, which is 101. And 9x is going to be equal to 90, so x is going to be 10. And that is example 9, and that concludes everything for 6.2. Thank you.